Alright, this video we're going to talk about the quotient rule, and probably after learning about the product rule, you probably are going to be able to quickly pick up on this. It's very easy. So exponents and the quotient rule. When you hear quotient, obviously or hopefully you hear division, and that's exactly what's going on here, okay? So it's very simple. Just like we did in the very last video when we talked about the product rule, I would like to just kind of review some of the definition of what an exponent is. You've got your base, okay? That's the number or the expression that is your big number, and then the exponent. That is that superscript is what we say in math. Exponent, that is the number that denotes how many times you're multiplying a number times itself. So like for example, if I had x to the, let's say, 5th, that's the same thing as saying x times x times x times x times x. X times itself 5 times. That's what an exponent is. It is not x times 5. That is not what's going on. And as you see here, x to the 5th is x times itself 5 times, okay? Again, this is known as exponential form, okay? It's that condensed form. So exponential form is the condensed form of the repetitive multiplication. Okay, so if you have it all written out and expanded out, we say that it's expanded form. It's a very creative way, expanded form. Also, before we move on, I'd like to review the product rule. The product rule, that is what you learned about when you had the product between two expressions. So the product rule, okay? The product rule says that if you have two terms with the same base and you are multiplying them together, again, product of two terms with the same base, you can add those exponents together. And we talked about why, because if we expanded those expressions out, we're able to recondense them back down into one single expression. So that's why you're able to do that. Okay, now but let's talk about what the quotient rule shows. Okay, so looking at an example of what the quotient rule is showing. If I have the quotient of, let's say, 4 to the 5th and 4 to the 3rd. 4 to the 5th divided by 4 to the 3rd, okay? Just like we did with the product rule, I'd like to expand this out, and let's see if we can discover what the quotient rule tells us and allows us to do. In my numerator, I have 4 times 4 times 4 times 4 times 4. And in my denominator, I have 4 times 4 times 4. Okay. Well, looking at this expression, I noticed something right off the bat. I noticed that 4 divided by 4 is the same thing as 1. So 4 divided by 4 is 1. Again, continuing on, I see another 4 times 4, or 4 divided by 4, which is also 1. And another 4 divided by 4, which is 1. So ultimately speaking, this is the same thing as me saying having 4 times 4 in my denominator over, well, everything in my denominator simplified away is just 1. So I have that this is equal to 4 squared. Hopefully your minds just didn't explode and burst outside of your skull. Like that commercial, I forgot what commercial it is. I saw it during the Olympics a lot, but hopefully your brains didn't just explode. Again, what I was able to do was divide away like terms, because 4 divided by 4 is 1. Those like terms divide away. And I'm left with just 4 times 4 in the denominator. It's very, very easy. Very, very simple. Maybe you noticed something in response to the answer and what you started with. If not, you might after this next example. So let's do another example. Let's say we've got x to the 8th over x to the 2nd. Okay, writing this out in expanded form, I have x times x times x times x times x times x times x. How many x's do I have? 1, 2, 3, 4, 5, 6, 7, 8. divided by 2x's in my denominator. Okay, again, continuing with the same idea as we just saw, whenever I have x divided by x, that's the same thing as saying 4 divided by 4. Anytime you divide a number by itself or a term by itself, it simplifies to 1. Okay, so x divided by x is 1. I have another x divided by x, which is also 1. Okay, so that leaves me with 1, 2, 3, 4, 5, 6 x's in my numerator. That's it. That's it. That's really it. 6 x's in my numerator divided by 1, which is just x to the 6th power. Again, hopefully you noticed something about what you started with and where we ended up, because that's where the quotient rule comes into play. So let's talk about the quotient rule, okay? Here's the quotient rule. The quotient rule says, if you are dividing two terms that have the same base, so a to the n divided by a to the m, it's the same thing as saying a to the n minus m. I can subtract those exponents. And that makes sense because when you subtract, you're taking away something, right? We'll look back at this example. What am I subtracting away? Well, I'm subtracting away like factors. Okay, I'm subtracting away like and dividing away like factors of 4's in the first example, and I divided away like factors of x's in the second example. So what the subtraction symbol represents in this situation is the taking away, the dividing away of like factors. So that's why you subtract here. Again, you have to have the same base. You must have the same base. You must have the same base in order to apply this rule. If you do not have the same base, you cannot apply them. You have to have like terms. Okay, so it makes sense if you put the quotient rule and the product rule side by side. With the product rule, you're adding. With the quotient rule, you're subtracting. With the product rule, you're combining your like factors into one expression. And the quotient rule, you're dividing away your like factors, which makes a whole lot of sense. All right, so let's look at some examples here. Okay, so let's look at an example of x to the 4th divided by x, just by x. Okay, what the quotient rule says we can do is, and just like I did in the last video, I want to show it to you in the long way, and then I want us to apply the quotient rule. So, if I was to write the numerator in expanded form, I'd get x times x times x times x. The denominator in expanded form, well, it's just x. Looking at my like terms, I see that I have x divided by x, which simplifies to 1. And I'm left with x to the 3rd, divided by 1, which is just x to the 3rd. Okay. Now, but the quotient rule says what we can do is we can take what we start with and we can say, okay, we can say, since we're subtracting or since we're dividing two terms with the same base, I can apply the product rule, or the quotient rule. Just like the product rule, though, anytime that you have a term without an exponent, it's understood that that exponent's 1 and you need to write that. You must include that or you might get confused and make an error. Okay, but the quotient rule says that since you are dividing two terms with the same base, you can take that base and subtract those exponents, 4 minus 1, which gives you x to the 4 minus 1, which is 3. Notice how we get the same answer. It's very neat, right? So cool. So neat. Goosebumps. I got goosebumps because I'm so excited about this right now. Alrighty. Let me nerd on to the next question. Next example. Just want to do a couple of these because these are very simple. And what I ultimately want to get us to being able to do is combining the quotient rule and the product rule together. So I want to do another example, and then we're going to work on combining some of those properties that we have already learned about. So let's say we've got 4 to the 3rd, y to the 5th over 4 squared y squared. What the quotient rule says is that since you have terms with the same basis, you can subtract those exponents, okay? But I can't subtract just any exponent. I can subtract the exponents that are applied to the 4's, so 4 to the 3 minus 2, and I can subtract the exponents that are attached to the y, so 5 minus 2, but I can't do anything else. I can only combine like terms. I can only subtract away like factors. Okay, and divide away like factors. So your final answer here is 4 to the first power times y to the third, which is really just 4, anything to the first power is itself. So 4 times y to the third. Very simple. Very, very easy problem. Again, I'm only combining like terms. I can combine my 4's, I can apply the product rules to my 4's, and I can combine my product rule to, or I keep saying product rule. I could apply the quotient rule to my 4's, and I can apply the quotient rule to my y's, but not together. I can't do that together. Hopefully your mind's not blown, and hopefully you're not completely confused. It really doesn't get much harder than this, except for we're going to do 2 more problems that are similar and then let you practice some problems. Okay, so here we go. Let's say I've got 2 squared times x to the third times 2 to the fourth times x, just x, okay, divided by 2 to the fourth times x squared times x. Boom. Okay. The first thing that I notice right off the bat is the fact that I've got 2's in my numerator and I have x's in my numerator that can be combined using the product rule, and I've got the denominator that has some x's that can be combined using the product rule. So what you always want to do is you want to combine that first. So what I'm always going to do, you're going to see me do when working these problems, is I'm going to rewrite this to put my like terms together. Okay, I put my 2's together, and then I'm going to put my x's together. Just like we did with the product rule, okay? Notice how I'm going to go ahead and add that exponent of 1 to that x. It's understood that that exponent's 1, but you need to show it. It'll help you when you're applying these rules. Luckily, the denominator's already set up where your like terms are connected and together. Again, there's an x that does not have an exponent, so I'm going to include that 1. It's understood to be 1. Okay, so what I want to do now is I want to apply the product rule in the numerator to combine my 2's. I want to apply the product rule in my numerator to combine my x's, and then I'm going to apply the product rule in my denominator to combine the x's in my denominator. So what do I mean by that? I mean, okay, well, I've got 2 to the 2 plus 4 times x to the 3 plus 1. Again, I'm combining my like terms. 2 to the fourth is lonely. He has no friends. Okay, so I'm going to leave him alone. But then I'm going to apply the product rule with my x squared times x. So x to the 2 plus 1. Combining and adding those numbers, I get 2 to the 6th times x to the 4th divided by 2 to the 4th times x to the 3rd. Now what I want to do is I want to apply the quotient rule. I've applied the product rule to simplify everything that I can, and now I want to apply that quotient rule. So I'm going to apply the quotient rule to my 2's because I'm dividing away factors of 2, so I'm saving 6 minus 4. Taking away 4 factors of 2 from the 6 given factors times x to the 4 minus 3. Again, I'm taking away 3 factors of x by dividing them out, so I use subtraction. So then your final answer is 2 squared times x to the first, which your final answer here is 4x. Okay, I know that's a lot, but again, it's always best for you to combine like terms first before you start applying applying any properties. Okay, but the only problem is here, in order to combine like terms, you've got to apply the product rule. So always combine like terms in your numerator and denominators if possible first, okay? And you'll do that by using the product rule. Let's do one more example and then I'm going to let you do some practice. Actually, I don't think this is going to fit on the screen, so let me drop it on down a little bit. Drop it like it's hot. Here we go. All right, let's say we've got x squared times y to the 4th times x to the 6th times z. Ooh, I like z. My name starts with z. Oh, let's just keep going. Let's say y to the 8th times x to the 4th. There we go. Boom. Divided by y squared times x squared times y times x. Boom. Ugly, I know, right? Okay, so my first step is going to be to combine my like terms in my numerator and denominator by applying the product rule. So I'm going to put my x's together. Okay, I'm going to say x squared times x to the 6th times x to the 4th. So my x's are now together. I'm going to rewrite it so that my y's are together. Y to the 4th times y to the 8th. And then times that lonely z. Divided by. Again, in the denominator, I'm going to combine my like terms. So I'm going to rewrite it so I put my x's together. So x squared times x. I can do that because everything's being multiplied. Times y squared times y. Okay, I'm going to combine those like terms by applying the product rule. So in the numerator, I'm going to say x to the 2 plus 6 plus 4 times y to the 4 plus 8 times that lonely z. He has to just tag along, even though he has no friends. Okay. Divided by, applying the product rule. I see that I have exponents that are not written, so it's understood to be 1. X to the 2 plus 1 times y to the 3rd. Simplify by adding, so I'm just going to say x to the 2 plus 6 plus 4, that's 12, times y to the 12 times z, that lonely z, poor guy, divided by x to the 3rd times y to the 3rd. And now I want to apply the quotient rule to simplify and divide away those like terms. Okay? So x to the 12 minus 3 times y to the 12 minus 3 times that lonely z. He has nobody to divide away with, poor guy. Equals x to the 9th, y to the 9th, z. And there's all multiplication, but you know your final answer needs to just drop those multiplication symbols. It's just understood that when they're side by side, you've got multiplication going on. That's about as hard as it's going to get for you guys. You might see a couple more, a little bit more complicated, but we'll work through those in class. Hopefully you don't have any questions. If you do have questions, you're welcome to comment on the video, and if I see them, which I probably won't since I'm on vacation, oh boy, poor guy. He's ugly. It's probably what Z looks like, and that's why he has no friends. But anyways, hopefully you understand this. I'd like you to practice this in class, and if you have questions, we'll handle it when I get back. Enjoy. Deuces.